All right, so first of all, you guys, when we're adding fractions, and today we're focusing completely on just adding, not any subtracting. But one of the things you need to remember when we're adding fractions is they need to have a common denominator. So that's the first thing you need to remember. You might want to write that somewhere. They have to have a common denominator. Okay? So looking at this first one, does it have a common denominator? Yes, it does. So therefore, I can just add straight across and the denominator will stay the same. Okay? So 6 plus 5 is 11. That one was easy, right? All right. Number 2, these are mixed fractions, and we need to get them back into the other form. So one of the ways we do that is we take 3 times 1 plus 2. It's kind of in a clockwise motion, so remember that. So 3 times 1 is 3, plus 2 is 5/3. Sure. So I got that 5 by taking 3 times 1 plus 2. All right. This next one, same thing. Yep, 3 times 2 plus 2, and that's going to be 6, 7, 8/3. Okay, do they have a common denominator? Yep, so I have a 3 on the bottom. Okay, 13/3. Okay. You can keep it in this for now, yeah.
Doesn't matter if you have it in like 4, 1/3.
You can change it back, yeah. So if you wanted to change it back, the basic thing is you could put it back in like this. We learned this back in chapter 7, I think it was. So 3 goes into 13 4 times. 4 times 3 is 12. You have a remainder 1. So this would be 4 1/3 if you put it back in a mixed fraction. Okay? But for my purposes and for this chapter, I'm okay with this method, okay? All right, so last one. We have an issue here. Houston, we have a problem. What's the problem? Okay, so one of the things you can do is break this down into its prime numbers. So what goes into 15? 3 and 5. What goes into 20?
5 and 4.
Okay. What goes into 4?
2.
Okay. So what we need to do is come up with a denominator that they both have 5s, so I don't have to worry about that part of it. But what is this one missing that this one has? It's missing the 2 sets of 2's, right? So I can, 2 times 2 is 4, so I can multiply both top and bottom of this one by 4. What is this one missing that this one has? A 3. So I can multiply top and bottom by 3. They both already have a 5 in it. No, because 5 times 15 and 5 times 20 still is not a common denominator. You just need to multiply them both by the missing prime numbers. Okay? Yes, you could multiply the 15 by the 20 and the 20 by the 15, and that way you would cover everything. That's one way of doing it as well. Okay? So 4 times 4 is 16. 4 times 15 is 60. 6 times 3 is 18. So 18 plus 16. 34 over 60. Could I reduce this?
Yeah.
Sure can. Okay, so if I divide them both by 2, it'd be 17 over 30. Okay? But like Sam said, the other way you can think about this, I'm going to change my pen color here just so I can show you this is a little different way. I could have said 4 over 15. I could have multiplied this one by 20 on top and bottom, and this one by 15 on top and bottom. Okay? You would have ended up with you would have had to simplify it further than what we did. I mean, it would eventually get down to 17/30ths, but so yes, you can do it that way. All right. Questions on this page? That's it so far. Okay, I got one more page. So that last page we were dealing with just numbers. Now we're going to bring algebra into it and bring in some letters. Okay? Now, same rules apply. Common denominator. Do these two denominators have the same numbers? Yes. So therefore, my answer on this is going to have 15 x squared y squared on the bottom. Okay? And then I'm just going to add like terms from the top. So it's the same thing as saying x minus 2y plus x minus y on the top. So how many x's do I have on the top? 2x. And how many y's? Actually, it's a -2 and a -1. That makes it a what? -3y. Okay? I'm going to take a minute to stop the video, and I want you guys to do 2 by yourself. All right? Okay, so what you guys should have gotten on this one is 5m minus 5n over 12m squared n. Okay? Because these two right here could have been combined. Okay? Okay. 2 more to go through, and then I'm going to let you guys work on your own. Okay, we have another problem here. What's our problem? Not the same denominator. Okay? So, looking at this one, it's already pretty much down to its primes. I can't really break it down any further. So, what is this denominator missing that this one has? A 2. So, I'm going to multiply top and bottom by 2 on this one. Okay, and what is this one missing that this one has? 3x squared y. Okay, so now we have 8y over 6x squared y. Now, if you're looking at this one, the first thing I want to do is make sure I multiply my coefficients. So it's 4 times 3, 12. X times x squared, x to the third, and then just a y. And the bottom is 6x squared y.
Why isn't, when you do 4x times 3x squared y?
Yep.
Isn't the y 4x?
I'm putting my 4 and 3 together, so that makes 12.
It's not like distributing anything?
Yeah, no, they're been put together. So x times x squared is x to the third, and then I have y there. Okay, now we can add them together. We finally have a common denominator. So 8y plus 12x to the third y. Can I put those two together? Really? No. So I'm just going to have to write them out on the top, on my numerator. And that would be my answer. Pardon me? Because these two y's, oh, you mean, yeah, you could actually do that. So this is a question. Can I take a y out of the numerator and denominator? Yes, I can. If I took the y out, factored out the y, I would have 8 plus 12x to the third over 6x squared y, right? And then I could do that.
Why can't you add the y to that, not to that 8
No. Well, so, okay, here's the thing you got to remember. You don't want to just cancel out. You want to factor it out first and then cancel it. Because this is what I see happen too often. I'll see, say, something like this, 8y plus 1 over y. People will think, oh, I can just do this. But you can't because it's being added. If you factored out a y from both the top and... So if it was 8y plus 1y squared over y, you could factor out a y on the top, right?
There's a 7.
Yeah. No, there wouldn't be a 7 there. I could take out a y. It would be 8 plus 1y over y. These would cancel. And then I would be just left with that. So, but just make sure you're not doing this. I see this happen way too often. Yes?
Okay, so why can't you just cancel out the last y? Go back.
Right here?
No.
Right here.
Yeah.
You can, but just
That one.
like this.
No, like the one with the 12 and the 6.
Right here.
No.
When did you add those together?
At the end. Yeah, like what you just did with the y's. Why can't you just do that?
Right here.
Yeah.
You can. I'm just saying.
Not with the 8y, just the 2 on the bottom. If that makes sense. You just cancel them out.
Just these two?
Yeah.
No, you have to do them all. That's the reason why you have to factor it. Okay?
And then I have a question.
Okay.
You said, why can't you make it?
Okay, so on this one, notice that this does not have a 2n. And this one does not have a 5. So I'm going to multiply top and bottom by 2n here. And this one by 5. So I will now have 10n as my denominator. And the top will be 2n times m minus 5n. And this will be 6 times 5, which is 30. So here's an issue that you may not have noticed, but I have an n in a parentheses. What do I need to do here? I need to distribute it. So this 2n times m would be 2n m. And then 2n times 5n is minus 10n squared. Okay, now my denominator is going to be 10n, but if you notice the top, none of them have common, none of them are common numbers, okay? So I'm just going to have to write them all out again. So I'm going to say 2nm minus 10n squared plus 30n, and that's my answer. Almost. Is there anything I can do to simplify this? I could take out an n. So if I take out an n off the top, I'll have 2m plus, oh, it's minus, by the way. That should be a minus. Minus 10n plus 30 over 10n. The n's will cancel. So my final answer on this is 2m minus 10n plus 30 over 10.
Question.
Yeah.
Why did you take the n out of the 2 and m and the 30, but not out of the 2? Oh, you did.
I did, yeah.
Because it's squared.
Can you guys see any other way I could have simplified this? Notice that they all have a 2 in them. So I could have divided everything by 2 as well. So if I did that, I would have an m minus 5n plus 15 over 5. And that is the most simplified answer.